Hello all, welcome to Circuits and Network class. Today we are going to deal with the Foster form and the Cauer form of the RL network. You can see that I have already drawn the circuits of the Foster form 1 and Foster form 2 of the network, and the equations have already been given, so you can just check that out. Now you can see over here that one thing that you have to note is that P0 over here is actually a constant. It is not a coefficient of any value of S, it is a constant, and H is the coefficient of S. Okay, H is the coefficient of S. And if you are considering the Foster form 2, you should note that P0 is the coefficient of 1 by S. Okay, P0 is the coefficient of 1 by S and H is the constant over here in Foster form 2. Now, how do you differentiate between the LC, RL and RC networks? LC network, it is having H by S into S square plus omega 1 square divided by S square plus omega 2 square and so on. So if there are S square terms, it means it is an LC network. Now, for the RL as well as the RC networks, there are no S square terms. There are only S terms. So that is S plus sigma 1 into S plus sigma 2 and so on, divided by S plus sigma 3, S plus sigma 4 and so on. There are no square terms. And similar is the case for the RC network. There are no square terms. How do you differentiate between the RL and the RC network? Now for the RL network, we can just take this particular example. You have 5 into S plus 1 into S plus 4 divided by S plus 3 into S plus 5. You take the solution of both the numerator as well as the denominator. Take the solution of the numerator and the denominator and look at which value of S is nearer to 0. You have over here minus 1, minus 3, minus 4 and minus 5. So obviously minus 1 is nearer to 0. So, and you just look at the value which is nearer to 0 is at the numerator. So, if the value at the numerator is nearer to 0, that means it is an RL network. And suppose the value of the denominator was nearer to 0, it will make it an RC network. Now, let us see how to find out the Foster form 1 for this particular problem. I am not going to explain all in detail. Foster form 2, you can do it on your own. Actually, you just have to find out the partial fraction expansion. It is as simple as that. Now, before starting the partial fraction expansion, you have to check over here the power of the numerator and the denominator. Now, you can see over here the power of the highest power of the numerator is S square, that is 2. And at the denominator also the highest power of S is S square, that is 2. Since both are equal, you have to divide it. How do you divide it? Well, you saw in the LC network also. In the LC network also, if the degree of the denominator is less, okay, that means if the degree of the denominator is less than that of the numerator, you have to divide it. The same method you have to use over here. So you have 5 into S square plus 5s plus 4 divided by S square plus 8s plus 15. You just do the normal division. So you have S square. I'm not going to take the 5 which was there over here. S square plus 5s plus 4 divided by S square plus 8s plus 15. So you have 1 S square plus 8s plus 15. You just subtract it. This get cancelled, minus 3s minus 1. Sorry, minus 11. Minus 3s minus 11. Now you can rewrite Z of S. Z of S is equal to 1 plus, that is quotient plus remainder. Your remainder is minus 3s minus 11 divided by the divisor. So I'll just rewrite the denominator. I can write it as divided by S plus 3 into S plus 5. It is correct, right? Now what do you have to do? You just simply have to do the partial fraction expansion. But you can see that you can take the minus sign over here common. Okay, you can take the minus sign over here common. So I'll just take that common and I'll show you what is the problem. Now you can see over here that there is a negative sign that has come up. Okay. Now while doing these problems, you should not have a negative sign because it means the poles are negative. It should not happen. Okay, you should not have a negative sign. So whenever a negative sign comes up, what should you do? You should first consider Z of S by S in such situations. Okay, consider Z of S by S. So your polynomial will change. Your polynomial will become 5 into S plus 1 into S plus 4 divided by S into S plus 3 into S plus 5. Now you can see over here that your polynomial has changed. Now do you have to do the normal division? You just look at the degree of the denominator. It is cube, right? S into S into S. That is 3. 3 is the power at the denominator and the degree at the numerator is 2. So since the degree of the denominator is greater than that of the numerator, you can proceed as norm. So you can find out A by S plus B by S plus 3 plus C by S plus 5. You simply have to use the normal partial fraction expansion. Okay, normal partial fraction expansion. I will just write down directly the values of A, B and C. You can solve it and find out. You will get the value of A as 4 by 3. B, you will get it as 5 by 3 and C, you will get it as 2. Now I will substitute the values of A, B and C. So you have this is Z of S by S, that is 4 by 3 by S plus 5 by 3 by S plus 3 plus 2 by S plus 5. Now what should you do? You have to multiply throughout by S. Why do you have to multiply throughout by S? Because on the left side you are having Z of S by S and you need Z of S. You do not need Z of S by S. So you are going to multiply throughout by S. Okay, you are going to multiply throughout by S. So what will be your answer? You have Z and S get cancelled. Then you have 4 by 3 plus 5 by 3 S divided by S plus 3 plus 2S divided by S plus 5. Now this is in our standard form. And you remember that what is the constant over here? Is it P0 or H? For the Foster form 1, okay, for the Foster form 1, P0 is the constant. And here are you having an H term? No, because there is no S alone. That is, if you are having plus 2S, over here H will be 2. But in this case, you are not having it so. And you have P1 is equal to 5 by 3. Okay, this is P1. Then P2 is equal to 2. Then you have sigma 1 is equal to 3. Sigma 2 is equal to 5. Now you can just substitute all of the values in your formulas and you will get the particular Foster form equation, Foster form circuit as such. Since you are having P1 and P2, you are having two parallel branches. Okay, so this is your Foster form 1. I'll just write down the final answers. You can just substitute the values in the equations and you will get the answer. You can just compare it with your answers. Okay, so this is the Foster form 1. Now, as a small work, you can just find out the Foster form 2. Okay, you can just find out the Foster form 2 of the particular network given over here. While finding out the Foster form 2, you always have to use Y of S. And fortunately, in our question, Y of S is already directly given to us. So you can write down now. In most of the cases, what happens is that they will not give the solution over here. It's not given whether it is an RL network or an RC network. So what you have to do is you have to find out the solution of the network, find out whether the numerator value is nearer to 0. If it is nearer to 0, then it is an LC network, otherwise it will be an RC network. So you can just find out the answer using all the formulas that has already been given. Please note that over here the power of the degree of the numerator and degree of the denominator are both same. So you have to divide it initially. Okay, first you have to divide it initially and you have to convert it into the form quotient plus remainder divided by the divisor. And then you can continue with the partial fraction expansion and you will get the answer. Next, let us just, as the final topic, we can also go through the Cauer form of the RL network. So, I'll just draw the general form of the Cauer form 1. for the RL network. Okay, so your coil form 1 is given by inductors in series and parallel resistors. And your coil form 2. What is the difference in the coil form 2? Everything is in the opposite manner. So you have R first, etc. And then you have the inductors in parallel. So this is your coil form 2. Now, there is nothing special that you have to do in the coil form 1 and coil form 2 of the RL network. It is same as that of the LC network. That means you have to do the normal continued division method. For the coil form 1, you take it in the normal manner. That is, if you are taking an example of Z of S is equal to, I will just take a random example, 2s square plus 8s plus 6 divided by s square plus 8s plus 12. Okay, first you have to check whether it is an RL network or an RC network. Okay, you have to check whether it is an RL network or an RC network. If it is, if the value of the numerator is near to 0, that means it is an RC network. Otherwise, it will be an RL network. Sorry, if the numerator is near to 0, it is an RL network. Okay, RL. Numerator near to 0 means RL, and the denominator nearer to 0 means it is an RC network. So what you have to do? You have to do the continued division method. That means you have to take s square plus 8s plus 12, and you have to take 2s square plus 8s plus 6. Sorry, I'll just take the bracket in this manner. And then 2s square and s, what you have to do? It will be 2 times. So you have 2s square plus 8 2s are 16s plus 24. And then you subtract it and you keep on continuing. Now for this particular problem, you can see that negative terms are arising over here. Okay? You are having negative terms. So if you are having negative terms, in that case you have to take y of s. Okay, this is common for both the coil form 1 and coil form 2. If ever negative terms are coming, then you have to take the reverse. You have to find out y of s. What did we do in the Foster form? In the Foster form, when you got negative terms, what did you do? You took z of s by s. Okay, even if in the Foster form 2 also you are getting negative terms, you have to take y of s by s. Whereas in the Cauer form, what do you do? In the Cauer form, both the Cauer forms you are using z of s. And if you are getting negative terms, then you have to take y of s. So you have to take y of s. Over here, y of s is equal to, there is no 2, s square plus 8s plus 12 divided by 2s square plus 8s plus 6. And now you do the continued division. That is 2s square plus 8s plus 6. And here you are having s square plus 8s plus 12. And you just keep on continuing. So here it will be half. So that will be s square plus 4s plus 3. You just do the subtraction. You can just do the subtraction. You will get 4s plus 9. And then you take 2s square plus 8s plus 6 over here. And then you keep on continuing. Now, one more thing that I want to mention over here. Over here, your first term is 1 by 2. Your second term will be 3 by 2. Your third term will be 8 by 7. Then you will have another term that is 49 by 50. 30. 49 by 30. And then 15 by 42. So you have five partial quotients. You are having 5 partial quotients. And the order for the Cauer form 1. The order for the Cauer form 1. First, you will be having the normal order for the coil form 1. You can just see over here. It is beginning with an inductor. So it should be L1 1 by R1, L2 1 by R2, L3 and so on. This is for the coil form 1. But what happened? You have taken y of s. Okay, you have taken y of s. And because of that, your circuit will be starting with the parallel resistor. Okay, I hope you remember all of this. In the case of LC network also, it was as such. Okay, this is continuing and here you are having the resistor. Okay, it will be starting with the resistor. So, in this particular question, your answer will be starting from the second step onwards. That is 1 by R1, L1, 1 by R2, L2 and 1 by R3. Okay, so this is something that you have to know. For the Cauer form 1, in the actual case it is starting from L1, 1 by R1, etc. Okay, but since you got negative terms, you had to reverse it. In that case, what will happen? It will start with the resistor, so it will be 1 by R1, L1, 1 by R2, etc. It is going to start from the second term onwards. For the Cauer form 2, what's the difference for the Cauer form 2? If you're taking the same polynomial, how are you going to start dividing? You know that when you start dividing, maybe you may get negative terms. Okay, I'm not going to solve it completely, but how should you begin? You should take Z of S itself. You should take Z of S itself, but you should take, for Cauer form 2, what should you do? You should take it in the reverse manner. 6 plus 8s plus 2s square. Sorry, you are going to take Z of S. So I have taken Y of S. I am sorry. I will just use my eraser. I'm just going to make some space over here. Okay, so in the Cauer form 2, what you have to do? Again, you are going to start with Z of S. Okay. Again, you are going to start with Z of S. And how will you do the division? You have to take the increasing order or the reverse order of what you took in Cauer form 1. How are you going to start? You start with 12 plus 8s plus s square. And over here, what will you do? 6 plus 8s plus 2s square. And you can do the division as normal. So what you have to do, you have to multiply by half. So you have 6 plus 4s plus s square by 2. Okay, and you can just continue. You just take it as normal. Okay. Yeah, you just do the division as usual. Your normal method. Okay, I hope it is clear. In the normal continued division manner, you can just subtract it. You will be getting again 5 values. But over here in the Cauer form 1, you took the order as L1 1 by R1, L2 1 by R2. In the Cauer form 2, the real order is you have to take the reverse order. That is R1 1 by L1, R2 1 by L2, and so on. Okay, so I hope these are the main things that you have to know. In the Cauer form 1, the order is L1 1 by R1, L2 1 by R2, etc. Whereas in the Cauer form 2, the order is R1 1 by L1, R2 1 by L2, etc. And if ever the negative terms are coming, you have to take Y of S. And when you are taking Y of S, from the second step onwards, your answer will begin. Your answer will be beginning from the second step onwards. So that means it's going to start from the resistor. 1 by R1, L2, 1 by R2, L3. And if in the Cauer form 2 you are getting negative terms, it will be starting from 1 by L1. Okay. So these are some of the things that you have to note. You can just do a Cauer form 2 as a homework. Okay. You can just do a Cauer form 2 as the homework. You can just try and solve this. You have Z of S is equal to 2s square plus 8s plus 6 divided by s square plus 8s plus 12. I'll just draw the answer over here for your reference. In case you are having any doubts, you can just refer these answers. So you are having 3 resistors and 2 inductors. The value of the resistances also I'll just mention over here. Okay, so this is the answer for the Cauer form 2 of this particular question. Okay, so I hope the foster form and the Cauer form of the RL network is clear. In the next video, you can study the foster form and the Cauer form of the RC network. Please stay tuned. Thank you.